Today, we're going to make a single material function or subgraph that moves, rotates, and scales our UVs. Let's go. So, translation, rotation, and scale, you're probably thinking, this is going to be really simple, but it's a little trickier than you might think. We're going to start out with the work that we did from last week's video, which is rotation. Rotation is the most complex part of this, and we covered how to set up this part of the graph last week. So if you haven't watched last week's video yet, go ahead and go back to that video and watch it and create this portion of the graph from that, and then we'll pick up from there. So after we've done the rotation part of our graph, and we've got our UV coordinates rotating properly, the next thing that we need to focus on is translation, which is moving our UVs left and right and up and down. So let's go ahead and disconnect the rotation part of our graph for now and just focus on translating or moving our UV coordinates. So we're going to take our UVs, and in order to move UV coordinates, we need to use add. So I'm going to put down an add node, and we're going to add something to the U and the V. We need to add a value to the U to move our UV coordinates left and right, and we need to add a value to the V to move them up and down. So I'm going to hold down the 2 key and click, and that's going to add a constant vector 2 node, which will allow us to add something to our U and our V. So here you can see we have 2 values, and the first value is going to get added to the U, and the second value is going to get added to the V. So if I want to offset or move my UV coordinates, let's just add like 0.1. Let's just add 0.1 and 0 for now and see what we get from that. Okay, so you can notice here that our UVs have moved over 1/10 to the left. And if I set it to 0.2, it'll move 2/10 and 0.3. And you can see that we're slowly moving over. So adding these values to our UV coordinates is slowly moving them. And I can add arbitrary values to the U and the V separately to move over by 0.3 and to move down by 0.5. So we're using add to move our UVs around. Okay, so now we have movement working, but the next question is how do we join that together with rotation? The tricky thing here is what order do we do these in? Do we do our rotation first, or do we do our movement first and then our rotation? Well, let's just try it and see. Let's first try putting our movement first and then our rotation and see what happens. So I'm going to take this value here where we're taking our texture coordinates, we're adding our movement, and then we're doing our rotation. So I'm just going to wire this in here and then reconnect this at the end, and we'll see what happens. Okay, now this looks a little bit weird. Before, when we had our normal rotation happening, we were rotating around our center pivot point. You can see if I zoom in here, this point here at 0.5, 0.5 is our pivot point, and we're rotating around that point. But if we do our translation first and then our rotation, now you can see we're rotating around some point that's moved off from the original point where we wanted it to be rotating, and that's because we're doing our transform or our offset first. So we've lost our pivot point, and this is a little bit unintuitive. We don't know exactly where our pivot point is, and if we were to change these values around, we would have to do a lot of rejiggering in order to keep that pivot point where we want it to be. So doing our transform at the beginning is obviously not going to work. So let's set this back to the way that it was, and we'll move our transform here and put it at the end. So here is the end of our rotation. And I'm just going to wire this into our add and then wire this into our texture. And now you can see we do have our offset working. We're translating our texture, but we're still rotating around the center. So we've preserved our pivot point. So we've learned that the order of these operations is really important, and we get different types of behaviors depending on which we do first. In this case, it makes sense to do the rotation first and then the translation so we can keep the pivot in its original location. All right, so we've got our rotation and we've got our translation. The next thing that we need to do is our scale. So let's go ahead and disconnect these UV coordinates and just focus on scale for a second. So in order to do scaling, we need to use multiplication. So we're going to take our texture coordinates here and we're going to multiply them by a value. And just like we did with our translation, we can scale on both the U and the V axis. So again, I'm going to hold down the 2 key and click. And now I'm going to connect this vec2 value to our multiply. So we're taking our texture coordinates and multiplying them by 2 values. One will be multiplied by the U and the other by the V. And this will scale our UV coordinates. So if we want UV coordinates that are exactly as they were when we started, we can multiply by 1 and they'll be unchanged. But if we want to skew and stretch our texture just a little bit, we can multiply by something else, like maybe 2 and 5. And now you can see that my texture has 2 tiles across and 5 tiles down. So this is how we scale. We take our original texture coordinates and we multiply them. If we use a vec2, we can non-uniformly scale, or we can give each of the axes a different value to scale by. We can also scale by just a regular single value, but that's going to scale our UV coordinates uniformly. So you can see I have the same number of scaling tiles in both directions. But if I use a different value like this, 2 and 5, now I'm scaling by 2 on one axis and 5 on the other axis. All right, so we've got our scaling working now. And now the question is, where do we put it in the order? So here we've got our rotation and we've got our translation. And where do we need to put our scaling? Well, the interesting thing about scaling is scaling needs to have a pivot. Just like with rotation, we need to scale around something. And we already have a pivot point here that we've specified for our texture coordinates. And that's where we're rotating around. And we need to use the same pivot for our scaling that we use for our rotation. And so that means we need to do our scaling somewhere in between this point where we've subtracted out our pivot and this point here where we've added it back in. So we either need to do it before rotation right here, or we need to do it after rotation right here in this area. So let's first try doing our scaling before our rotation and see what happens. So here we're subtracting out our pivot point, and then we're going to put in our multiply node to scale this. And let's take a look and see what happens if we do this. Now, here, this is really weird. You can see we're getting some skewing happening here. And this is because of the order of operations. Because we're doing our scaling first and then our rotation, it's ensuring that our scaling, our non-uniform scaling is staying correct on the U and the V. And so when our rotation comes around and you can see that it lines up, it's keeping our two columns and our 5 rows the way that we had it. But this is not exactly what we want, this skewing and stretching happening because of the order of operations. So what we're going to do is we're going to set this back the way that it was. And then we're going to take our scaling, and instead of putting it here before our rotation, we're going to put it after our rotation, but before we add back in our pivot point value here. So here I'm going to take the result of the append and connect it to our multiply, and then I'm going to connect our multiply to this point where we add back in our pivot. And now you can see that we're doing our rotation first, then our scale, then we're adding back in our pivot, and then we're doing our translation. And this order of operations gets us a behavior that gives us expected results. You can see that we're scaling around the center pivot, and we're rotating around the center pivot, and then we're offsetting. So now we have a correct transform with the order of operations happening in an order that will give us expected results. We're doing rotation, then we're doing our scale, then we're doing our movement or offset or translation. Okay, so we've got our entire function, and that's super cool. The only thing left to do is to convert this into a material function so that we can use it in other materials. And let's go ahead and do that. So I'm going to open up my content drawer here and just kind of scroll down to the bottom, and I'm going to right click and pick materials, material function. And I'm just going to call this MF for material function underscore transform UVs. Because this is going to be our material function that does all of the UV transforming we need. Now, we've already got our whole function created. We made it all here. We just need to take this and copy and then paste it in here. And now we can pass out the result. And then the last thing that we need to do is just convert each of our input values into exposed parameters. And so the way that we do this is just search for input and add function input nodes. So by default, they come in as vector 3, and we actually want these to be vector 2. So I'm going to change our function input to a vector 2. And just for setting the defaults, I'm going to set our translation defaults to 0. And we need to name this. Right now it's just called in. But let's name this offset. And we'll plug that into our add. And then I'm going to copy this one to make a new one. And we're going to call this one scale. And the defaults are going to be 1 and 1. And we're going to plug that into our multiply here. And then I'm going to copy and paste this. And this one is going to be called our pivot. And we're going to give it defaults of 0.5 and 0.5. And we're going to wire that one in here and also connect it over here where we add it back in. And then finally, we've been using this time node here for our rotation value, but we actually need to add a new input so that we can define our own rotation. And this is just going to be a function input scalar. And so I'm going to wire this one into cosine and sine and go ahead and delete our time value here. And for input on this one, I'm going to give it values of 0 for defaults. Now, the other thing that I need to do is if I want to keep the default values of any of these inputs and use the function in another material with nothing connected to the ports, I need to check this use preview value as default. This is going to allow the port to be empty and for an empty port to be okay, and for it to just go ahead and use this default value if the port is empty. So I'm just going to check this checkbox on all of my inputs so that in my function, in my material function, it will be okay for me to leave some of these inputs empty. Okay, so our material function is done. We have a function that does UV translation, rotation, and scale. And maybe the last thing that we should do is expose this UV value so that we can plug in our own custom UVs. So let's go ahead and do that as well. I'm going to copy and paste this guy, and we'll just call this UV. And then I'm going to plug that in here where our UV coordinates used to be. And then the last thing that I'm going to do here is I'm going to take our texture coordinates and plug that into our preview value here. And what that's going to do is, now that I have this UV input, if I leave this one empty, it will go ahead and use these texture coordinates. So let's save our material function and take a look at what it looks like in a shader. So I'll switch back over to this material that we've been creating here, and I'll grab our MF transform UVs and drag it into our material. And now you can see I have this MF transform UVs material function that we created here. And I have scale, pivot, pivot one. Oh, looks like I made a few mistakes here. This is why you always want to drag your material function in and preview it. So let's go back. This one that I've called pivot one here is actually supposed to be called rotations. And we'll save that and switch back here. I think that UV should probably be at the top, and then maybe offset, rotation, and scale, and then, yeah, I'm gonna reorder these as well. So let's switch back here. And for UVs, I'm gonna come down here and set the sort priority to 0. Then I'm gonna do offset as 1. Then I'm gonna do rotations as 2. And then I'm gonna do scale as 3. And then I'm gonna set the pivot point as 4. And we'll save this and switch back over to our material again and add our material function. And now you can see the order that we just gave it in these sort priority boxes is now controlling the priority or the order that the ports show up in our material function here. So we have our UVs first, then our offset, our rotation, scale, and pivot. So let's go ahead and replace all of this with the function that we just created. So we can connect our MF transform UVs. And you can see that none of my ports are connected here, but I'm getting good values because I set those defaults up when I was creating the material function. Okay, so I don't need to connect my UVs because I know that the UVs are connected there. But if I want to set up some values here, I can do an offset of maybe 0.3, 0.5 like I had before. And then for rotation, I can add in my time again. Time multiplied by a small number to slow it down. 0.05. And then I can add in some values for scale. I think we used 2 and 5 before, just as an example. And by default, my pivot is set to 0.5, 0.5, so I know that I'm rotating around the center, but I can also set a pivot value if I want to, just to test this out. So now we're going to be rotating around the lower right corner because I've got a pivot value of 1, 1. Okay, we've got a transform UV node that's working perfectly, and we're ready to use this in another shader. So in the videos in the coming weeks, we're going to be using this MF transform UVs function for something cool that's coming up. So be sure that you tune in for next week's video when we're going to continue to build off of what we've done so far. And now the last thing that we need to do is switch over to Unity, and I'll show you how to do or to create a subgraph there that does the same thing. All right, so here we are in Unity, And you can see we're picking up where we left off last week. So here are the nodes that do our rotation. And I've already added in our multiply node to multiply by a vector 2 to do our scaling. And then I've added in this add node here to do our translation. So just like we did in Unreal, we're doing our rotation and then our scale, and then we're adding back in our pivot point offset, and then we're doing our translation. So we have a complete transform shader here in Unity, and the last thing that we need to do is convert this into a subgraph. So I'm going to open up our Unity project here and go to our shaders folder, and I'm going to right click and pick create shader graph subgraph. And just like we did in Unreal, I'm going to call this translation UV transform. And then we're going to open up our UV transform node. Now, Unity is a little bit different here. What we're going to need to do is add some values in our blackboard. So we need a value for our incoming UV coordinates. We need a value for a vector 2 value for offset. We need a vector, let's see, we need offset rotation. We need a float value for rotation. We need a value for, we need a vector 2 value for scale. We need a vector 2 value for our pivot. I think that might be it. Okay, so let's switch back to our shader. We can go ahead and grab all of this and paste it in. And then for our output, the result of our transform subgraph is UV coordinates. So I'm going to open up our inspector here and select our output node. And we're going to name this UVs, and I'm going to change it from vector 4 to vector 2. Now I'm going to wire the result of the whole thing into that, and now we have our results going out. And now we just need to take these values from our blackboard and connect them up where they go. So for UVs, I'm going to drag this in here and connect our UV value there. For offset, we're going to drag the offset in. Let's just maximize this so it's have a little bit more room to work with. Our offset is going in here with our add node at the end. Our rotation value is coming in up here at the top, so we're going to replace time with our rotation value. Our scale value is multiplied in right here. And then our pivot value is subtracted out here and then added back in over here toward the end. So let's go ahead and delete out our hard-coded values in favor of our subgraph inputs. Just kind of clean things up here, and we can delete our hard-coded values. Now I need to set some defaults. So for UVs, actually, you know what? It would be better to use UVs, like the real UVs, as the default. So what I can do for that is I can use a custom binding and add, I'm going to add this node called branch on input connection. And so what this is going to allow me to do is to branch my shader based on if an input is connected or not. So I need to tell it which input I want to be connected, and that's my UV input. But you can see it won't let me connect that here, and that's because I need to come over here to this checkbox in my inspector called Use Custom Binding. So I'm going to check that, and then I'm going to give this a label of UV0. And now I'm going to connect this to my input here. So it says when the UV input is connected, use the value of the UV input. But when it's not connected, in that case, I want to use my UV coordinates as they are by default. So when it's not connected, use those. Otherwise, use the value of the input port. And there we go. I've set up that input port as a subgraph to use these UVs by default if the port's not connected. And for these others, I can just give them regular default values. So for offset, I'm going to give them values of 0. For rotation, 0. For scale, I'm going to give them values of 1, because if they're values of 0, it'll be infinitely small. And for pivot, again, we're going to give it defaults of 0.5 and 0.5. Okay, so my UV transform subgraph is complete. And now I can just add it to a graph to test it out. So I'm going to switch back here to this graph and drag my UV transform node in here. You can see I've got UVs, offset, rotation, scale, and pivot. And for my UVs, the default is UV0, just like I set up here. I set up my UVs as UV0 to default as that if my connection is not connected. Okay, cool. So let's go ahead and hook this up and make sure that it works just like this big pile of nodes is working here. So I can drag these over here, go ahead and disconnect that. And I want to connect these UVs into my texture sample here to see if everything's working correctly. Let's turn back on our preview, turn off our blackboard and our inspector. So for rotation, I want to use time again. So there's my time node, and I'll wire that into rotation. Now I'm getting some good rotation there. For offset, I think I used like 0.3 and 0.5 in my example. So you can see how those values are offsetting. And for scale, I use like 2 and 5. And then I can change my pivot point as well if I want to. But we can see that our UV transform subgraph is working perfectly, and we're ready to use it in future shaders. So come back next week. We're going to start using this UV transform node to build something kind of big and kind of cool. So I hope you get excited for that and come back and take a look at what we've got going next week. And in the meantime, have a great week, everybody. Thanks for watching.